Welcome back. It's Mr. Cannell again. This is the final lesson in our series about finding equivalent fractions and simplifying. We're going to look back at the question set at the end of your previous lesson, and then we'll review the main points from the whole series. Do you have your work with you? Have you got a pencil and paper? Of course you have, because you knew I was going to ask you. Here are the calculations that Mrs. Furlong left you with in the last lesson. She certainly kept you busy, and me. Did you have a go at finding the answers as mixed numbers? Mrs. Furlong also wanted you to put them in order of difficulty. Now you might have been able to decide which were easiest and which were hardest without doing the calculations. And the ones that you thought were the hardest might be different to mine or someone else's, and that's okay. Let's have a look at the first one. Did you remember the generalization in the yellow box for multiplying a fraction by a whole number? The numerator of the fraction is multiplied by the whole number, and the denominator remains the same. Did you partition so that you multiplied the whole number 5 by 2, and then the fraction 5/6 by 2? So we've got 5 multiplied by 2. Nice and easy, that's just 10. 5/6 multiplied by 2. Multiply the numerator 5 by 2, and the denominator remains the same. So that's 10/6. 10 and 10/6. Can you see a problem? That's it. We can't have an improper fraction within a mixed number. Mixed numbers are made up of a whole number and a fraction, a proper fraction. Okay, so 6/6 is 1 whole. So 10/6 is 1 whole and 4/6. Now we can simplify that 4/6 to 2/3. So now we have 1 and 2/3 plus 10. 11 and 2/3. Is that what you got? Well done if you did. Let's look at question B. Again, we can partition. Did you add the whole numbers? 4 plus 2 is equal to 6. And then add the fractions. 8/9 plus 5/9 is equal to 13/9. We'll need to sort out that improper fraction again, won't we? Because we can't just leave it as 6 and 13/9. 9/9 is 1 whole, so 13/9 is 1 whole and 4/9. So altogether we have 7 and 4/9. Now we need to remember to do a final check to see if we can simplify. Well, 4 and 9 have no common factors other than 1, so we can't simplify it any further than that. Did you get that one too? What about question C? Well, this looks quite straightforward. Can you remember the generalization? You found this one with Mrs. Hussain. When adding fractions with the same denominator, just add the numerators. Do you remember that the generalization works for subtraction too? When subtracting fractions with the same denominator, just subtract the numerators. So we'll just subtract the numerators. 15 minus 9 equals 6. That gives us 15 quarters minus 9 quarters equals 6 quarters. 4 quarters is 1 whole, so 6 quarters is 1 whole and 2 quarters. Hang on, what could we do now? Yeah, of course. 2 quarters is equivalent to 1/2. So our final answer is 1 1/2. Have you got that one? Well done. It's time for question D. This one has 3 fractions to add. Remember to just add the numerators again. Did you get the improper fraction, 31/6? Do you think we can simplify? No, that's right. The 31 and 6 have no common factors. So now we just need to convert to a mixed number. Can you tell me what you did? Pause the video while you tell me. Was it like this? 6/6 make 1 whole. So how many groups of 6/6 are there in 31/6? Well, using the 6 times table, I know that 5 whole groups of 6/6 make 30/6. So 31/6 is equal to 5 1/6. That's great if you got that one. Finally, for these questions, we have 6 3/8 minus 2 7/8. What did you think? Well, already I'm thinking this looks tricky because the 7/8 in the subtrahend is larger than the 3/8 in the minuend. There's going to need to be some bridging. Now there are quite a few different methods you could use here. Mrs. Furlong used a number line, so let's see that method again. Start at 6 3/8, and then if we subtract the whole number part, so we're going to subtract the 2, that takes us to 4 3/8. Now we can use the 4 to bridge. So we're going to subtract 3/8, and then we need to subtract another 4/8, which takes us to 3 4/8. Oh, now 3 4/8. What do you think there? I'm going to put the 3 in on this point on the number line. Is there a simpler way of writing that? Well, look, 4/8, 3 4/8 is halfway between 3 and 4. That's it, you've got there already. 3 4/8 is equivalent to 3 1/2. Now that we know that the answer is 3 1/2, I think you could try some of your own subtraction strategies to see if you can find another method for doing this question. Maybe even a more efficient one. Okay, so here are our answers. Which calculation did you choose as the easiest? They all needed some thinking about. This is what Mrs. Furlong and I thought, but don't worry if you disagree. We thought that C was the easiest, as it was quite easy to subtract the numerators and the simplifying was okay. Then we chose D. Adding the numerators was quite easy, and then changing to a mixed number was a little bit harder than the previous one. We thought B was next, as once we'd added the fractions, we needed to convert to a mixed number, but there was no simplifying required. We chose A next, as the multiplication was quite easy, but the simplifying from 10 10/6 to 10 5/3, and then to 11 2/3, that took a bit of working out, didn't it? Finally, we chose E as the hardest one. What did you think? Subtracting needed bridging, and then we had to simplify it as well. If you chose a different order, that's fine. It's up to you. Now we're going to review the lessons in our series. In the first 3 lessons, Mrs. Lambert and Mrs. Holmes showed you examples of fractions that had different numerators and denominators, but shared the same value. Can you remember what they were called? Shout it out to me. Come on, louder, you really do know it. Okay, let's put that word into this stem sentence. Sometimes 2 fractions have the same value. We call these equivalent fractions. That's right, equivalent fractions. We're going to find out how many equivalent fractions we can make using these number lines. Have a look at the number lines you've got here and tell me what the whole has been divided up into for each one. I'm going to pause the video so you can do that. Let's check how each line has been divided up. The top line has 3 equal parts between 0 and 1. 1, 2, 3. We can say the stem sentence together. The whole has been divided into 3 equal parts. Each equal part is 1/3 of the whole. What about the middle line? The middle line has 1, 2, 3, 4, 5, 6 equal parts. So can you say that STEM sentence for yourself about the middle line? Come on, I want you to say it. The whole has been divided into 6 equal parts. Each equal part is 1/6 of the whole. How many equal parts did you count in that bottom line? Did you count twice to make sure? Hopefully you counted 18 equal parts. Let's say that STEM sentence together. The whole has been divided into 18 equal parts. Each equal part is 1/18 of the whole. Well done. Our activity now is to see how many equivalent fractions we can find using these number lines. So for example, 1/3 sits at the same position on the number line as 2/6. What about the bottom line? How many equal parts did we say there were? That's right, there were 18. So 1/3 sits at the same position on the number line as 1, 2, 3, 4, 5, 6 18ths. So 1/3 is equivalent to 2/6, and they're both also equivalent to 6/18. How many more equivalent fractions can you find using these number lines? Any positions on the number lines? Pause the video and see how many you can find for yourself. Welcome back. Did you find some more equivalent fractions? I hope so. You might have them in a different order to me, but I went from 1/3, I went to 2/3. So 2/3 on the number line sits at the same position as 4/6, and that's the same position on the bottom number line as 12/18. Did you get that one? Did you find some more equivalent fractions? I hope so. I'm moving my blue line now to here. Now I don't have an equivalent fraction in thirds on my top line, but here is 1/6, and 1/6 is in the same position as 3/18. So 1/6 and 3/18 are equivalent fractions. From 1/6 we can go past 2/6 because we saw that that was 1/3 earlier on, and now we're at 3/6. Now 3/6 doesn't have an equivalent fraction in thirds, but it does have an equivalent fraction on our bottom line of 18ths. What was that one? 9/18. That's right. 3/6 and 9/18 are equivalent fractions. Is there another fraction that we can see that those two are both equivalent to? Come on, shout it out to me. Louder. Yeah, that's right. It's 1/2, isn't it? A half is equivalent to 3/6 and 9/18. It's halfway between 0 and 1. We can see that quite clearly using our number line. Here is an octagon. My question for you is, what fraction of the octagon is shaded blue? This is a bit like a question that Mrs. Holmes gave you at the end of lesson 2. Have a pause for a think and come back when you're ready. What have you decided? Well, we could divide the whole into 8 equal parts. It's an octagon, 8 equal parts. Each equal part is 1/8 of the whole, and we've got 6 parts shaded, so we could say that 6/8 of the octagon is shaded. Is there another way we could express that? What if we move this blue triangle here to this position here? Does that help us to see anything? Oh, hang on. I've got here, this isn't an 1/8 anymore, is it? That's not an 1/8 anymore. What's that? It's 2/8. It's like these 2/8. But also, that looks like a different fraction as well. How many equal parts are there now? There are 1, 2, 3, 4 equal parts. So each equal part is 1/4 of the whole. How many of those are shaded? 3 equal parts. So we could say 3/4 of the octagon is shaded blue. And we've seen that 6/8 and 3/4 are equivalent fractions. Is that what you came up with? Well done if you did. Are you ready for a challenge? You've done quite a few of these now. I'm going to introduce you to my friend Mr. Lu from Shanghai. This is us when I was in Shanghai a few years ago. Our daughters have become friends too, and they send messages and photos to one another. This is Mr. Lu's cat in her Christmas outfit. He does like dressing her up. As well as photos of his cat, sometimes he sends me maths puzzles called Dong Nao Jin. Use your head puzzles, and that's what you're going to do now. We know that 1/4 and 3/12 are equivalent fractions. So can you read these equations and figure out what goes in the missing number box? Pause the video and come back when you have a solution. Did you solve it? Did you find out what goes into this missing box? Well, if 1/4 and 3/12 are equivalent, then 1/4 and 3/12 is the same as 1/4 plus another quarter. So 1/4 plus 1/4 would be 2/4. And here then, if 1/4 minus 3/12, what's that going to be? Well, that's just the same as 1/4 minus 1/4, and that comes to 0. Could you create some similar calculations using this pair of equivalent fractions? I think you can. You could pause the video now, or you could come back later. Perhaps you could test out your calculations on somebody in your home. With Miss Heaton, you notice that some equivalent fractions can be found when there is a vertical multiplicative relationship between the numerator and the denominator. So the denominator is a multiple of the numerator. For example, here's our number line again. 1/6 is at the same position on the number line as 3/18. So 1/6 and 3/18 are equivalent fractions. For both fractions, the denominator is 6 times the numerator. 1 times 6 is 6. 3 times 6 is 18. We can use a vertical multiplicative relationship to find an equivalent fraction to a unit fraction really easily. The denominator is always 8 times the numerator, and the numerator is always 1/8 of the denominator. I can scale my numerator as much as I want to. I could have a numerator of 5. 5 multiplied by 8 is 40. 40 is 1/8 of 5. I could have a numerator of 100. 100 multiplied by 8 is 800. 1/8 of 800 is 100. I could have a numerator of 1 million. 1 million multiplied by 8 is 8 million. 1 million, 8 millionths. All these fractions are equivalent to 1/8. For which of these non-unit fractions can we easily use the vertical multiplicative relationship to find an equivalent fraction? Pause the video for some thinking time. What have you found out? What did you decide? Did you decide that 2/8 would work easily and 4/8 would work easily? What were your reasons? I think there are at least a couple of reasons, aren't there? If we look at the denominators, 8 is a multiple of 2 and 8 is a multiple of 4. So those ones work easily. 2/8 is equivalent to 1/4. So for 1/4 and 2/8, the denominator is always 4 times the numerator. What fraction is equivalent to 4/8? Shout it out to me. Go on loudly. That's right, 4/8 is equivalent to 1/2. All fractions equivalent to 1/2, the denominator is 2 times the numerator. That's right. So why can't we use the vertical multiplicative relationship easily to find an equivalent fraction for 3/8? That's right, because 8 is not a multiple of 3, so it won't work easily. We need a different method. With Miss Eaton, you also looked at equivalent fractions that had a horizontal multiplicative relationship. In this example, the numerator and denominator have both been scaled up by the same factor. Can you spot what that is? That's right, they've both been scaled up by a factor of 6. So we can say 4/5 and 24/30 are equivalent because both the numerator and denominator have been scaled by a factor of 6. Remember, fractions that are equivalent have the same value. They're the same proportion of the whole. One of the most important aspects of fractions is being able to notice the horizontal multiplicative relationship between two fractions. You really need to know those multiplication tables. How can we use a horizontal multiplicative relationship to find the missing number to make the statement true? 3/8 is equivalent to something over 72. Use your times table knowledge to find the relationship between the denominators. Can you then complete the stem sentence? Pause and come back when you've got a solution. What did you find? Did you find that the denominator has been scaled by a factor of 9? So the numerator also needs to be scaled by a factor of 9. Multiplying the numerators, 3 multiplied by 9 is 27. Let's say the statement together. 3/8 and 27 over 72 are equivalent because both the numerator and denominator have been scaled by a factor of 9. Can you say it for yourself? Well done. Very good indeed if you got that one. Next, I want to know, is this statement always, sometimes, or never true? When the numerator and denominator are multiplied or divided by the same number, the value of the fraction remains the same. You read it. What do you think? Pause and come back when you've made a decision. Well, I hope you've decided that it's always true. It's really important, isn't it, that equivalent fractions have the same value. This is Mrs. Lambert's favourite statement, and it's really the key to equivalent fractions. Can you remember what we mean when we say that a fraction is in its simplest form? I did this with you in lessons 13 and 14. Here was our generalisation. A fraction is in its simplest form when the only common factor of the numerator and denominator is 1. So which of these fractions are in their simplest form? 1/7, 6/10, 7/12, 12/16. Pause the video while you have a think and then come back. What did you decide? Did you say that 1/7 is in its simplest form? That's right, because 1/7 is a unit fraction, so it must already be in its simplest form. Did you say 7/12 is in its simplest form? 7 and 12 don't have any common factors, so 7/12 is already in its simplest form. What do we need to do to write 6/10 in its simplest form? How will we write 12/16 in its simplest form? What do we do to convert to a simplest form? Here we are. To write a fraction in its simplest form, divide both the numerator and denominator by their highest common factor. So, to write 6/10 in its simplest form, we need to divide both 6 and 10 by their highest common factor. Their highest common factor is 2. That's right. So 6/10 is equivalent to 3/5. What's the highest common factor of 12 and 16? Is it 2? It's 4, isn't it? 4 is the highest common factor. So divide 12 by 4 and divide 16 by 4. Our equivalent fraction, our simplest form, is 3/4. Well done if you got those two. Here's one final practice question. Join the pairs of equivalent fractions. One is done for you. Well, yes, it's the easy one that's been done for you, isn't it? 1/2 is equivalent to 2/4. For the others, you're going to need to think about what you've learnt about multiplicative relationships, vertical and horizontal. Think about what you've learnt about simplifying fractions. You could go back in the video if you want to. Pause now and see if you can pair up the fractions. Have you solved it? Did you find the horizontal relationship between 2/5 and 6/15? If we multiply the numerator 2 by 3, we get 6. If we multiply the denominator 5 by 3, we get 15. So 2/5 and 6/15 are equivalent to each other. The others were trickier, weren't they? 8/12 and 10/12. Well, they can't be equivalent because they've both got the same denominator, but different numerators. So what did you do? Did you simplify the fractions? That would be the best thing to do, because the others, there's no easy horizontal relationship between them to easily spot. So to simplify then, did you simplify 8/12 to 2/3 and 10/12 to 5/6? So we're looking at which other these other two fractions, which ones are those going to match up with? Which one is 2/3? Which one is 5/6? Which did you find? Did you get 14/21 is 2/3? So there's a matching pair. And 25/30 is 5/6. So there's a matching pair. Well done. Very well done if you got that. Well, here we are. You've now completed this set of lessons about equivalent fractions and simplifying. It would be great if you could write about what you've learned so you could show your teacher. Maybe you could draw a mind map. You could include the stem sentences and generalizations that you've been saying. You could draw some images and write some examples. All these things will help you to remember the work you've done in the future. On behalf of all the teachers who have been teaching you in this section, we'd like to thank you for your hard work and for joining in so well. Well done.